Hey, what's up guys? Welcome to Sunday stream time. We are going to be looking at this Band of Viking 8001. Customer claims that this has some DC offset on the speaker terminals. He said there's about 5 volts DC on the speaker terminals. Now, these amps always have DC on the speaker terminals. They are a single rail amplifier, full bridge amplifier. So there's always about half DC rail voltage on the speaker terminals. That's how they work. And then the sine wave swings down to ground and up to top rail. But the guy said that there's 5 volts across them. There should never be any DC voltage across them. So we're gonna have a little relax, and have a look at this while we have a catch up and talk about some audio things, do some Q&A, catch up with you guys, see how you've been doing. So already in the live chat we have, actually that's too small. Already in the live chat we have YouTube, standard. Simo02, thanks for dropping in, bro. How's it going, Larry? How's it going, Ricardo? How's it going, Yalon? How's it going, Waves? Hope you're all having a lovely Sunday. Just getting back off this Banda 8K. What's up, David? And DC offset at the speaker terminals isn't that common on these, to be honest. When the outputs die, for example, you just get nothing. You just get protect. So the fact that there's DC on the terminals suggests that maybe this is powering up, but there's just a drive circuit fault. So what do we have here? Let's just have a visual inspection first. I'm going to spin it around this way. I always like having the power supply side on the right. Don't know why. Whoa, that is a freaking chungus of a copper block. So I'm sure that there's a fuse in line with the power wire, which is all that's important anyway. Fuses never protect amps. Unless it's a really small amp, maybe then they protect some damage, but generally no. Uh-oh, mic is off when I switch to the hat cam. Thank you very much. There's always teething issues with this. Let me switch back to that and add the camera in. Okay, apologies for that, guys. Yeah, I forget that I'm using the JVC camera today, so I need to add the mic in. But I was saying that my guy here has fitted the absolute brick of a copper bar in place of the fuse. This thing ain't going nowhere. This whole board's gonna melt before that anything happens to that copper bar. What a chungus. That's what I was just cracking up at. Team No Fuse FTW. Not that fuses protect amps anyway, unless it's a small amp. Yeah, that's my bad. Always teething issues. I've switched back to my old camera here. I was using a DJI Osmo, but turns out that the USB from my PC doesn't supply enough power to keep the Osmo charged, and it draws too much power from the USB from the PC, so it causes some dropouts. So, DC offset on the speaker terminals. What's going on here then? Quick visual inspection. Okay, we have no obviously burned power supply FETs. That's a good sign. I mean, there definitely is something funky going on over here. Like, these look like they've been soldered to at some point. That's interesting. Okay, so let's take a note of that. This might have been repaired at some point in the past. Doesn't look like it's ever had an output section repair though. These factory joints look pretty factory. These solder joints look pretty factory. So let's go ahead and check to see if we've got any shorts on any of the output FETs here. Okay, all good so far on that side. All good so far on that side. Ah, okay, well there's no obviously dead shorted output MOSFETs. Power supply, we're charging the power supply caps there, and no dead FETs either. Okay, so there's no dead FETs for certain, that's for sure. So why else might we have DC offset on the speaker terminals? Well, we're either going to maybe have a drive circuit fault, maybe one of the inductors is snapped off, doesn't look like it. We could be missing... Oh, hey, these rail caps, they feel bulged. That wouldn't necessarily cause DC offset, but might be a good idea to replace these. Now, this is the Band of Viking 8K, alright? So, these guys, this was originally the Band of Viking 7K. What USB device just reconnected? Concerned now. What camera isn't going to be working? These are working. Yep. That's. Oh, okay. It's my little set of buttons down here for switching the cameras. That screws up. Needed to key. The USB port is very dodgy on that, so that's fine. So the Banda made a 7K which looked like this, and then they bumped it up to an 8K, and to do that they just increased the rail voltage. Everything else is exactly the same. These caps are 200 volt caps, and especially if this is being fed with like 15.2 volts, the rail voltage is like very close. So these get pretty cooked. So these are all very bulged outwards. So we probably want to go ahead and change those anyway, regardless. But let's just do a quick. We're probably going to have to power it up to see why we've got DC offset. But the other reasons why we might have DC offset is a drive circuit fault. So if we just do a cheeky zoom in to the drive circuit here, we have basically 4 amplifiers on the same PCB. So it's a monoblock amplifier because they are it's in full bridge, push-pull, and also we have 2 amplifiers paralleled on each side. So you've got a 2010 driver, a 2010 driver, and you've got 2 FETs here, which is 1 channel, and another 2 FETs here, which is another channel, and they both parallel after the inductors. So if one of these channels has a drive fault, then it will definitely cause some DC offset on the speaker terminals. So that's something we can look at as well. I was doing a quick visual inspection to check none of the supply resistors for these drivers are burned or anything to suggest that the driver is shorted and has burned. Those resistors, the 4R7s, are all looking good. The resistors coming from these guys, which feed PWM to the 2010s, though they look fine as well. These chips themselves look intact, and over this side again, not seeing any burnt resistors here so far, all looking okay. Alright, well, visually we don't really seem to have any issues there, so I'm going to go ahead and give some power to this board and power it up and see if we've got any DC offset, see if there's any switching issues on the output section here. So let's just slap some cables in here. It's been a hot minute since I worked on one of these, to be fair. Okay, remote is in. So let's increase our power supply to, I'm just going to go nice and safe at about 9.3 volts, and because this is a more powerful amplifier, we're just going to be safe with a bit of eye protection, always good to have. And we're going to power it up and see what we have on all of the output FETs here before power up, so just with a little bit of rail voltage, and then again once we fully power up. We're going to see what happens. Yeah, that copper bar, that would have cost a fair bit. That's not a cheap bit of copper, that's a big thick bit of copper. Did you find the JL schematics useful? I haven't had to use them yet, but thank you very much nonetheless. I'm sure when I feel like I need to use them, they will come in handy, but yeah, I haven't needed to use them yet. But thank you very much for sending those over. I guess you sent them over, going by that comment. I'm going to be sending you a 7K very shortly. Well, the more the merrier, as we like to say. So, a little bit of rail voltage please, sir. Okay, there's 15 volts on that FET. We have 4 volts, 10 and 2, because it's obviously dropping. It's dropping quite quickly. So I want to just grab my second oscilloscope probe here as well. I'm going to turn both channels on, and I'm going to be looking to see whether we have any difference between these two outputs. Obviously, this being a full bridge amplifier, both positive and negative speaker terminals are an active output, and they need to be the same. There mustn't be any DC offset between them. If there is, then there's an issue. So let's have a look at the scope screen and power that up again. I'm going to probe both terminals right here. Let's have a look. Okay, a little bit of DC there as the rails build. That can be normal though. Okay, let's turn that voltage up a little bit, and let's let the rails fully build. I'm going to let about 6 or 7 amps in there now. I'm just going to let the amplifier come alive fully. I'm just going to monitor the rail voltage here, on the terminals. Okay, the amp's telling me low battery, which makes sense. I'm like at 9.3. I can't remember what the minimum voltage requirement for these is. There we go, now we're coming alive. Okay, so let's go up to 50 volts and let's check. Okay, well we've got no DC offset there. That looks perfect actually on the oscilloscope. Yeah, there was no DC offset there at all. So, but maybe when we connect a speaker, there might be a bit of DC offset. It might pop the speaker up. So what I'm going to do now is power the amplifier up, and I'm going to go around and look at all the pulses on the output section. Just before I do that though, it's never a good idea to have a Class D amp of this caliber powered up for a long time without a load across the terminals. So I'm just going to go ahead and drop a big dummy resistor across the speaker terminals here, just to give it a load. They don't like idling with nothing connected, or playing with nothing connected for very long, so just going to quickly drop that on here. Okay, one in there, and one in here. Oh man, get in there, come on. Just having to unscrew the terminal a bit, just to get the wires in. That is one cool thing about the band, is they do use pretty strong terminals. Nice. A drop of my spaghetti. Looks like the microphone is clipping a fair bit here actually. Let me know if the mic's clipping for you. I'll knock the gain down a little bit. Yeah, I'm just going to knock the gain down by about 3 dBs, just in case it was clipping there. Okay, so yeah, with that load connected now, we can power it up. I'm just going to have a look at the Class D switch waves and just make sure they all look even and equal across all 4 banks of outputs on this amplifier. So let's power up again. What is the rail voltage? I'm curious. With 9.5 volts going in. What do we have on the rails? Okay, there's a fair bit of noise on the rail, probably because the rail caps aren't really doing their job very well. But this is the Class D switch wave. So we have 120 kilohertz there, looks pretty nice. Go along to the next bank. 120 kilohertz. Yeah, looks alright. Looks alright. And this one here. Yeah, looks okay as well. And this one here. Yeah. So, I'm currently not seeing a problem with this. Oh man, why is it always when I go live I get the no fault found? We'll connect to sub and we'll check that it plays audio, but currently no fault found, which is always typical whenever I go live. Always happens. But although there's no fault found, these rail caps definitely could do with replacing. This is the rail voltage. If we have a look on the scope, if I zoom in and go AC couple, that's currently the ripple on the rails. So it's a fair amount from the SMP, from the power supply. I don't think that those caps are doing a very good job. So we're going to power the amplifier off and just let all the rail voltage dissipate for a sec, and then I'm actually going to use my ESR tester to confirm what the rail capacitance is of this bank. So we've got 4 capacitors and they're each 1,000 microfarads, so we should have 4,000 microfarads there or thereabouts. So we're going to test that with the meter and see whether that's still the case or whether they're bad. I mean, they definitely feel bad, they definitely feel a bit bulged. But sometimes that can be a bit deceiving, than not actually, it's just like the tops of them. So let's just grab ourselves a couple of test leads. One test lead. Two test leads. Hi Sam, sorry I'm not closer to you. I would have given you one of my 2 Steg Nico 1.40K to analyse. It's a unique amplifier in terms of construction. All the best. Well, no problem, buddy. I appreciate the thought, but that's fine. We're not always next to each other. Sounds like they're pretty big amplifiers. I'm not really familiar with them. We don't get them here in the UK. Low battery is a fault on my 7K, and I didn't know there was a fuse inside. Would the amp still power up if the internal fuse is blown? No, if the internal fuse is blown, then you'll get a flashing orange light on the front, and it will state low battery or fuse error. If you've got a solid red and blue light, if the red and blue, no sorry, if the red and orange are lit up solid, red and orange solid, then you have an output side short and blown output MOSFET, and that's not to do with low battery. That's just what these amps do. They love to pop output FETs every now and then. Oh, but you're saying low battery is the fault on your 7K? Yeah, in that case the fuse is probably just blown. Just pop the back off and replace it, or copper bar it. What's the PWM IC for the power supply in those Taramp Space 5K? Got one that's roasted. The last 3 ISs seem to be 524. UCC something, I think it's a UCC something 7. You can just drop in a 4427. Yeah, just drop in an IR 4427, it'll be fine. I've just got an SNI 6K that has been kicking my butt playing music. Nice. You have the orange flashing. Well, in that case, the amp's probably fine. You're just blowing the fuse, my friend. Alright, so we're going to go ahead and check the rail capacitance. Let's just get this on the right mode. Okay, yeah, we're on capacitance anyway, because we were reading the capacitance of my skin just there. So, has all the rail voltage dissipated from the board? Let's have a look. Yep, all gone. So, ground is just ground anyway on the bloody heatsink. These are common output side grounds, so, and then rail is just going to be either of these bars here. So we're just going to go ahead and on the heatsink and on here, and let's see what the capacity is of the rail. Okay, we have 3,300 microfarads with an ESR of jumping between 0.5 and 0.8 ohms, which is a little high, and the capacity is definitely reduced. So yeah, not ideal. I mean, this amp will still be fine, it will still play. There's not going to be any, it's not going to make any less power. Having 800 microfarads less capacity and possibly slightly higher ESR, that would just mean that there's a bit more ripple coming through from the switch from power supply to the output section, which would matter for a high quality SQ mids and highs amplifier or something where you can hear the noise floor and the hissing through the speakers. For a subwoofer amplifier, you're never going to notice that. Never going to know. So yes, while those caps definitely probably should be replaced, and it would be good practice, and you know, it would prevent them from failing in the future and taking out the power supply, I'm still going to give the customer a choice. I'm going to be like, look, I've looked at your amplifier, I've powered it up, no fault found. I'm going to test obviously with a sub just now in a minute, but I'll give him the option. I'll say, hey look, the rail caps, they look like they could do with replacing, but to do so requires stripping the entire board out of the heatsink, la la la, so it's going to be X amount of money. Do you want me to do that? You won't notice any difference in how the amplifier plays. It will just be a bit more, you know, it'd be good for it in the long term to do that. So, but I'll give him the option of either having it back just with a diagnosis fee, very cheap, or I can replace the rail caps. But let's just plug it into a sub just to confirm that we don't have any DC offset when there's actually a speaker connected. Poor copper bar is bent. It does actually look a bit sketchy. The copper bar on here does look a bit. It does look a bit sketch. It kind of looks like it's not making a super flat contact on this plate here. It's just kind of got the edge there touching. The contact area is pretty low of that, but it is very, very tight. I'm sure it's fine. What's your opinion on Sundown Salt series amplifiers? So they are not bad amplifiers. They are very overbuilt in terms of the current capabilities across the output section and the power supply. They're using good modern MOSFETs. The architecture is old though. So they're basically a very old circuit design, but with like high power modern MOSFETs kind of thrown in there. And the boards are not, the circuits are not particularly well optimized. They're not like a super optimized drive circuit. It's kind of using older architecture with new MOSFETs. It's a bit of a mishmash, but they do work well. They do make a ton of power, and they're very dynamic, and they do, you know, they do what they're supposed to do. However, because they are an older architecture, the reliability isn't quite what it could be if it was a modern architecture. There's no like health check mode on the startup, and when they do fail, they fail catastrophically. So if you've got a Salt amp, just pray to the heavens above that it doesn't fail and it doesn't blow, because if it does, you're looking at a very expensive repair bill. Whereas with a more modern amplifier, even that's maybe not technically quite as headroomed and as technically good and beefed up, if it did fail, then especially with one with a health check mode on startup, you would be looking at a way cheaper repair bill, much easier and cheaper repair. So yeah, it's and also the Salt amplifiers are so expensive. I almost can't recommend them just because of how unbelievably expensive they are for the power. When you're looking at other brands that you may or may not consider as good, you might think, oh, this isn't as good as an amplifier. Yeah, but you could buy flipping 3 of them for the same price as a Salt. So yeah, I'm not saying they're bad amplifiers, they're great, but I just don't think they make sense for the average bass head to consider. You know, they're expensive and you're not even getting a bespoke circuit design. Like I love Jacob, I love what he's doing, I love the R&D he does on his subs. I think his subs are fantastic. I think that he's really putting a lot of, you know, they are bespoke subs. You're not going to buy a Sundown subwoofer anywhere else. It is a Sundown subwoofer coming from Sundown, designed by Sundown. The amps are not the same like that. Taramps are Taramps amplifiers, they're bespoke. Alpine are Alpine amplifiers, they're bespoke. Well, all the Brazilian brands are bespoke for their company. You know, Pioneer are bespoke. Alpine, JBL are bespoke, pretty much, most of them. Audison are bespoke. Helix, Focal, most of them are bespoke. So those will carry a higher price because you're paying for all of the R&D that went into designing that board from scratch. Whereas the Salt amplifiers, they're not a board designed from scratch. You can get the same circuit pretty much in a Salt from you know, other brands that are using the same basic layout from the same factory. So, do we have any DC offset on the speaker? Let's have a look. Ah, we've gone green! Incredible Hulk's come back. Let's just unplug the... Okay, so, speaker here. I'm just going to power it up. try and get a cool camera angle here. There we go. Hey. This used to be my hat cam, but I haven't got it on the hat at the moment. So that's great, just gonna have to have this for you. Alright, so just make sure that the speaker doesn't move while we're powering it up. No, no movement at all while we're trying to power it up. Okay, now let's see. So the driver does actually come in a touch. It sucks in a tiny amount. Now, most amplifiers like this will have a DC offset adjustment potentiometer. And there is a potentiometer here. This TR1, trimming potentiometer 1. And it is in the right area for adjusting the duty cycle for each side. So I might give that a little spin and see what happens to the DC offset. Doesn't look like this amp's ever been repaired though, so that's kind of interesting how that's happened. So let's give it a little spin. It's kind of glued. It's actually was like painted over almost. Okay, yeah, we're getting it to spin now. Okay, so let's power it up and let's give it a little spin and see if the driver moves at all while it's while we're spinning it. Okay, that's less. Okay, that's more, so I need to go a little bit this way. A little bit more this way. Almost there. Now we're pushing out, so now we've gone too far. Ha! Nailed it! No more DC offset. So, like I said, I'm going to give the client the option to have the rail caps replaced, but I'm also going to advise him that in the short term at least, it's not going to make any difference to how the amplifier performs or sounds. So it's up to him whether he wants to have those replaced or not. But there's still a decent percentage of their original capacity there. They're just a little bit stressed. I'll maybe advise him to knock down the battery charging voltage a little bit, because I suspect this is at like 15.4 or something stupid like that. I'd like to see you do a proper setup and review of the DD-ZVL link module sometimes. Thank you. Is that a... so I haven't been following DD for years now, but is that the thing that you can link up multiple amplifiers of different brands, or does it only work with Digital Designs' amplifiers? Your info about the Edge 1800.2 2-channel power supply mod is great. I did about 20 of them. Nice! Excellent. I'm really glad about that. That's really great. Were you able to see that fault happening on your setup as well? That's really cool. I'm really glad that that's helped some people out. Does it distort with audio? That's a good point. Let's plug some audio in and let's just check to see how it sounds. It shouldn't do, based on everything that I've seen so far of the circuit, but let's have a check. So turn the frequency generator on. Okay, we have movement and it's pretty clean. Sounds great. Yeah, sounds real nice. Definitely no issues there. Perfectly functioning amplifier. So that was a nice easy one. Got some options for you next. So next we're going to look at a Taramps amplifier that I haven't actually ever looked at before. I didn't even know it existed actually. Or maybe I did know it existed, I just forgot about it. What are your thoughts on the Down for Sound amps, sub-amps? I don't know because I have never seen one, because we don't have them in the UK unfortunately. So yeah, I can't really comment, but what I will say is that obviously JP hasn't designed them himself, so they are going to be, once again, a generic factory circuit. It's going to be an older design, it's going to be maybe similar kind of stuff to what you find in the Soap, I don't know for sure, because I've never looked at one, but I've looked at obviously guts pics of them and they are just a kind of older generic circuit design. So it really depends on how much they cost versus how much power they make and also their reliability, which I can't really comment on because I've never had any experience with them over here in the UK. Joseph says, I'll send you a picture on WhatsApp. Let's have a look. Hi RTS, how's it going? Uh-oh. So, Joseph Hammond in the YouTube chat has opened up his Banda Viking 7K, which is flashing orange at him, and you can see there that we have a copper bar with no fuse. So that means the fuse is not blown. What is all that? Who's jizzed on the copper bar? What's that all about? Yeah, so the area in the middle where that little 3-pin chip, it's a transistor is, they always get hot. That's not a problem. It looks burnt, it's not, it runs really hot, and it just discolors the board over years of being used. If it's flashing orange, then yeah, that means that it's not getting enough power. When it's flashing orange and you're trying to power it up, what do you have the amp connected to? Do you have it connected to a car battery or like a proper vehicle setup, or do you have it connected to like some kind of power supply indoors? Because these take a few attempts to power up on a low current power supply. I still have some of your Basso Profondo rebasses still archived from back in the day. Nice! I have actually started back up on Basso Profondo. I uploaded a video on Basso Profondo this morning. Yeah, I did. I had a go just doing a rebase again. It's been a long time since I've done any rebases and I was kind of missing it. So I did a rebase using completely different software to I ever did before. It's Let Go, I can't remember who by. Really nice track, sounds pretty sick. I'm quite happy with the rebase. I used Cakewalk, which is a modern free door. I used to use Cubase, so I'm using very different software now, but I think it came out okay. And I also put out another video on Basso Profondo, which is telling you guys how you can use Audacity to rebase tracks in a far simpler way to what you might think. Most people who are doing rebasing with Audacity will be generating sine waves and putting them in place, you know, in the correct places in the track. That's not what we're doing here. We're doing something a little bit more simple, much quicker, but that has, in my opinion, arguably better results. There's two methods of making bass deeper in that video, so go watch that after the stream if you like. It's really cool. The channel is just Basso Profondo. You can just search for BP Rebase on YouTube and the channel will come up. Alright, so let's get the screws back into this Banda Viking 8K, and let's jump on now. Has anyone ever heard of the Taramps DSP 3000. So it's not the HD 3000, it's not the MD 3000, it's not the Base 3000 or the Smart 3K, it's the DSP 3000. So that kind of insinuates that the amplifier would have a DSP, active DSP on board, which would mean probably connecting it via USB. Except there's no USB ports on it, so I'm a bit confused and I want to have a look and see what it's all about. So here it is, the Taramps DSP 3000, and this is failed probably by the fact that it's here, and I'm really curious to see what about it is DSP, because like I said, it doesn't have any USBs or anything. Dumb simple power. That is a very valid point. It could not mean digital sound processor. Is that what DSP stands for? It could mean something completely else. What else could DSP stand for? Damn, she fat. Damn subs. Don't sing Pharrell. My boy NCP Lin coming in with a 200 kz. Well, man, that is very generous. The fact that it's orange means that it's like a reasonable amount of money. I've no idea how much that is in GBP, but I found you on TikTok some months ago, and happy to see you on YouTube too. My Crunch P4175 went into Protect last week, and I found blown amp stage transistors. What do you reckon, blown 2? That is sick, man. Good on you for giving it a go, man. Absolutely, that's sick. Definitely keep it up. Oh, damn. And you can definitely fix this. So a Crunch P4175. Send me some pictures of the board, please, to my Bearvids Facebook page, facebook.com/Bearvids. I think it's that simple. Send me some pictures just now. Let me know when you have, and I'll have a look on the stream for you. Thank you once again for the extremely generous donation. That's very, very kind of you. I'll buy some solar flux. I do need some more, actually. I'm starting to run low on my chip quick. And it's bloody expensive. This is £30. Orange is 20. That is a good chunk. That is a big chunk of money, man, for just throwing at someone on the screen. So thanks once again, man. That's extremely generous of you. Just real quick, I'm not too happy with how the camera looks. Filters, color correction. It's a little bit like shadowy and dark. Reduce the contrast a bit. Yeah, it's too contrasty, and then I want a bit more brightness. And then gamma. That looks a bit more kind of natural, doesn't it? Maybe I need a touch more contrast, touch more saturation as well. It's a bit unsaturated. There we go. That's a little bit better. That's a bit better. DSP means display. It's only a voltage meter. Huh. So, no, it doesn't actually. It tells you what it means on the front. Let's have a look. Right, DSP 3000. Digital Signal Processing. Oh, there's a 2-ohm version as well. Stanky high rail voltage inside. Get ready for that. So, what is DSP about this then? Let's have a look on the side. What do we have on the side? So we have level, high pass filter, low pass filter, bass boost, the same as you generally always will have. Monitor, which will just be the monitor. I know that for a fact. It was just going to be the 3 LEDs that come with these. We've got left and right inputs. Now on the PCB, let's have a look and see whether there's any more hints on the PCB. This chip is not normally here. What is that? Qu'est-ce que c'est? Qual? I'm just going to mess around with dark bang up the brightness, bang. So this camera's only ever really looking at PCBs, so we can kind of go hard on the contrast, and that makes it look a bit better. So what is that chip? That is, I'm just going to drop. There we go. You can read it a bit easier like that. STA 389A by the looks of it. STA 389A. STA 389A. STA 389A. Is that a read? No, I haven't read that right. Maybe it's STA 309A. There we go. That's what it is. Multi-channel digital audio processor with a DIDX. Don't do X-rays. That's what that stands for. So we have 8 channels of 24-bit DDX, direct digital amplification. Okay, well that's wasted because this is a monoblock amplifier. Greater than 100 dB of signal to noise ratio. Well, I guarantee the output section and the SMP of this amplifier is killing that spec. Selectable 32 kHz to 192 kHz input sample rates. Right. Can you Bluetooth to this amp? I don't see an antenna anywhere. 6 channels of DSD input. Digital gain attenuation. Volume update. Channel master. Up to 10 independent 32-bit user programmable biquads. Yeah, but how do you program it? You can't plug a USB in. What is the purpose of this? I'm gonna power it up and see whether my Bluetooth comes alive. But I'm not seeing an antenna anywhere, but it could be on the other side. So yeah, it's a DSP chip. Lots of complicated stuff for setting this and having it work in the circuit the way you want. So, okay, with that in mind, can we power this up? What's wrong with it? Does it have any dead outputs? There's a bit of visual damage I can see actually here in the middle of the board. Got like this very cooked, what possibly used to be a resistor. But it's no longer there, whatever it was. Yes, R13. So what was once a resistor is no more, and the pads are also gone, and also the trace that went here. What's interesting though is the trace kind of looks like it was supposed to be not there. Did you know what I mean? Like, that's very, very sharply, finely cut there. And I don't know, what would that be connecting? That is connecting something here. Man, this has been messed with before, hey? This has been proper messed around with. Look, we've got missing capacitors here. C19 and, no, C19 and C, whatever that is, 61, were once upon a time fitted and are no longer fitted. What else has been done with this? This has come from another technician over here in the UK, so it very well possibly has been messed with. We've got a power supply MOSFET over here. This one here looks like it's been replaced, but none of the other ones look like they have. What batch are you? No, you're the same batch, so that's either factory or someone's just touched that up for some reason. Maybe it was snapped in the lead or something but didn't fail, who knows. Let's just pop that back on there for a minute. Can't find anything in the manual about DSP programming, so maybe the DSP has like a preset program by Taramps. So yeah, actually, if we look here, basically over at the preamp section, we don't have the normal regular op amps and stuff that would make up the preamp section. You know, for the low pass filter, high pass filter, that kind of thing. We don't have any op amps at all, actually. We come in the RCAs basically straight into this, which is going to be like an analog kind of audio interface thing. I've seen that before in head units. Then we just basically go straight into the bloody DSP chip, and these potentiometers will be adjusting parameters on the DSP. This is interesting. So let's check for any shorted output FETs, because I want to get this thing powered up and see whether it connects via Bluetooth or anything like that. Alright, so the outputs all seem alright. Dead rectifiers, that can sometimes happen in these. These actually look like they've been replaced. Yeah, that rectifier has been removed for sure at some point. Power supply, again, fine. Right, so let's power it up and see what the crack is. I'm also going to check my messages from the technician that sent me this to see if, I can't remember if he said anything about what was wrong with this. They wasted so much potential of that S3 microchip DSP. You're right, they did. What the heck? I kind of don't understand the purpose. Maybe it was like, maybe this was like an experiment for them, for the engineers and the programmers and technicians to get used to and to learn about using these DSPs, for them to then maybe be used in a more complex DSP product from Taramps in the future. Who knows? But I do have contacts at Taramps, so I could probably ask and I'll probably get an answer. So, let's see what we have going on in here then. Right. Okay, it would help if my remote was connected properly. There we go. Right, let's check the output rails. Are we building a bit of rail voltage? Yes, we are, 19 volts. Okay, so let's check for Class D switching when this thing comes alive. Let's go here. This is a 2 ohm version, so it's going to be pretty strong on the rails here. Find somewhere safe to go off the rail, the switching. Right, well, we have a blue LED, no protection, but we don't have any Class D switching. Okay, so we're going to have to work our way back, and annoyingly this has been looked at by somebody else. So we're going to have to kind of worm our way back through the circuit and figure out what's going on. Ah, you know what? It's got a lifted pin. Why has it got a lifted pin? The pin of this driver, pin 3, has been lifted, so that's annoying. We're going to have to put that back. Okay, rail voltage has almost disappeared. Oh, actually, I wasn't actually looking at the correct place for the Class D switching. So let's just see whether we have any Class D switching. Okay, nothing on that one. Nothing on that one. No, so no Class D switching anyway. So right, let me just check my messages and what did the previous technician say about this? Why do we have a bunch of stuff lifted in the drive circuit here? Right. Right, got a couple for you. 500/1, that was back in November. So it's more recent than that. I got a Taramps 3K2M for you to have a look at. Right, no explanation as to what the issue initially was or anything, so we're just kind of going in blind and we're going to have to figure it out for ourselves. So yeah, what I'm going to do is wait for the rail voltage to dissipate, and then I'm going to put everything back, reconnect that pin there that's been lifted here, and work our way back and see what's going on. And this resistor, is that critical? What did that do? What's that connecting? That's connecting this. Is this ground perhaps? Let's see, is this ground? It's not. However, it does have continuity to the RCA ring on the RCAs, so it appears to be a ground of some kind. Oh wait, no, we do have continuity to ground. Okay, so yes, that is ground. And it looks like we have ground on both of the sides of this capacitor. Interesting. That's not normal. Right. We have ground on pin 3 here as well. Well, that's definitely not normal. So let's just remind ourselves about these drivers. These are great. These are the SI8244BB. I really like these drive ICs. They're pretty stout. SI8244BB. And let's remind ourselves of the pin outs, because I can't remember off the top of my head. I'm feeling pin 1 might be the PWM input, or is it pin 3? Skyworks. So pin 1 is PWM. Pin 3 is VDDI, which is VDDI. Where's the normal pin out of this thing? Here it is, VDDI, and the explanation of the pins. Here we go. Input power side supply terminal. Okay, so we seem to have a short between the power supply to the drive ICs and ground. So it's either one of the drive ICs themselves is shorted, or the supply for it that is shorted. So yeah, 3 and 4 are probably shorted here. Yep. Right, well, first things first, I think I want to remove the both of these drive ICs and see if the short goes away. Well, we know that this one isn't shorted because this one has its leg lifted. That explains maybe why the leg's lifted up on there. So maybe we could trace back, and what is feeding this with VCC? Well, this resistor here, R13, this appears to be feeding VDDI. So, okay, so the short is probably after this resistor, because this burnt out pretty bad. So if the short is after this resistor, then it's got to be either one of these drive ICs or one of these capacitors. So let's just start removing stuff, I guess, until the short disappears. We could put some current through the short and see what gets hot, but there's not that many components here. It's much quicker just to start removing stuff, I think. I sent you a photo on Facebook. Excellent. I shall check that in just a minute. Right, so that drive IC is probably fine because it's got its leg lifted and the short's still there. So let's just check this one. Yeah, I suspect this R13 is probably going to be a 4R7, something like that. Maybe a 1 ohm, like Nicholas said. R47 in the 1 ohm version. Nice. It will be the same in the 2 ohm version then, because that resistor doesn't have any relation to the output power or anything like that, so it'll be a 4R7. That's good to know. My guy David coming in with a 10 chuffs. Thank you very much for the 10 chuffs, my friendie. I appreciate that. He says, I do electronics as a hobby and I had no knowledge about amplifiers. I've been watching your videos for a long time and I learned so much. Thanks for sharing with us. Greetings from Switzerland. Yo! Greetings to Switzerland. Thank you so much for the very, very generous donation there, my friend. I'm really glad that that these videos have been useful for you. That's why I do them, to share the passion. This is something I enjoy, and I'm sure that lots of other people can get enjoyment out of it as well. So if we can all learn how to do this together, we can all get enjoyment. Thank you very much. And Performance has some internal shown of the 1 ohm version. Wow, you can zoom in that far. Usually their photos aren't that high resolution, but that's great. Thanks for checking that out. Let's have a look at the picture that Giannis, sorry, completely butchering your name there, has sent over. And this will be of, I can't remember what the brand was now, Crunch I think it was. Oh no, Giannis sent a photo on Facebook of the resistor. Oh, brilliant, thank you very much. And this is Jacob, the guy with the blown crunch. Let's have a look at the picture that he's sending. He sent it on Imager. Bro, why don't you just send it as a picture in Messenger? Why are you sending an Imager? Okay, never mind. That's fine. Oh, this is because this is like a forum post. Okay. So this is a Class AB amplifier. Okay, Jacob, honestly, chances are here that it's literally just a pair of dead transistors. The drive circuits in these are all discrete and they're pretty robust. I would be quite surprised if you had any dead drive transistors. So my advice here, these transistors are very cheap, these 1695 and 4468. You don't have to replace them with that exact model of transistor though, by the way. You might find that that's difficult to get hold of because it's a very old transistor now. So maybe look at something that is an equivalent that you can drop in, a modern replacement. If you're not sure, then maybe ask around on some forums for some suggestions for what to drop in there. I don't have any off the top of my head right now. I'm not so good at transistors. I'm better at MOSFETs, not so good at like these big Class AB transistors for just having model numbers off the top of my head. Yeah, definitely you should just be able to drop in replacements. You'll obviously have to strip the board to get to the underside to solder. But provided the emitter resistors, which are these great big green resistors here, yeah, provided, oh, manual focus, provided that those are not open, provided that they are still the correct resistance, then chances are everything else is probably okay. So yeah, give it a go, replace them, see what happens. Alright, so we've removed that driver. Has the short disappeared? Probably not. Probably something weird like a cap. Okay, short has not disappeared, so let's keep removing stuff until we find what's shorted. Gonna remove these two little caps next. What's up, Adrian? How's it going? What's up, Pradeep? Okay, so how's either of those? Got rid of our short. No. Interesting. Okay, so let's have a think. We're not connected to the circuit that supplies that voltage. But we do have a short to ground somewhere. Possible that it's this chip. I mean, maybe not, because what's that pin, that end one? Have a look at the data sheet again. That is, oh, that's also VDDI, so we have 2 pins for VDDI, so okay, that's fine. So they're just connected anyway. Okay, so what else is connected to ground around here that could be shorted? How about these little drive buffers over here? See here, we've got these 2 little SC1 and SC2. So we have ground on one of these, but not on any of the others, it doesn't look like. So that's unlikely to be shorted. Let's check some of the diodes around here. Well, this is curious. I'm kind of running out of things that could possibly be shorted. Might have to just dump some current into it and see what gets hot. Well, we still have VDDI connected because the previous technician didn't realise that this chip has 2 pins for VDDI. So we could still have a short in this one. So let's remove that, and if the short is still there, then I think we're going to be dumping some current into the board and seeing what gets hot. So I think there was a bit of confirmation bias there, that because pin 3, which is VDDI, was lifted, that the short wouldn't be in this chip, but we forgot that this chip has 2 pins, both VDDI. I'm a bit annoyed that these capacitors have been removed though, because I don't know what value they were. I suspect they won't really have deviated much from the datasheet. I could have a look at the datasheet, see if there's an example circuit so I can work out what value to put there, but... Hey, the short's gone! So the previous technician was so close! It was this close! But, yeah, the chip has 2 pins for VDDI. So that's why the short was still there when the pin 3 was lifted. Alright, nice and easy. Let's just drop in a couple replacement drivers then. SI2 or 8244BB. So we've got a brand new one right here. Now, do I use the one remaining one that was probably fine? I'd like to fit 2 fresh ones, you know, from the same batch if I can. Let's see what I've got. I'm actually running a bit low on these. That is a 17 batch, that is a 17 batch, that is 16 16. Okay, so I've got 2 here, which are the same batch. I don't honestly believe that matching batches of drive ICs is super critical in a full bridge amplifier. I think it's critical in a half bridge where you have output sections in parallel, but I don't think it's super critical with a full bridge. Nonetheless, we are going to match the batch of the chips. Let's just go practice. What's your hot air gun temp? Well, the temperature reading says 440, and that's Celsius. But obviously the hot air coming out the end is wildly dependent on the length of nozzle and how close to the tip you're holding it. So like hot air gun temperatures don't really mean anything. You just kind of have to figure out a number for your unit that does what you want to do with how you work. RTS is talking about high voltage transistors. I imagine you're talking to somebody in the chat rather than about this amplifier that I'm working on. Hi, can Class D amps go into Protect? And for very little reason. So going into Protect isn't a Class D thing. Amplifiers will have protection circuits that are completely nothing to do with the architecture of the amplifier. You can have the exact same SMP, power supply and protection circuit in a Class AB versus a Class D, etc, etc. So not really. An amplifier is only going to go into Protect when one of the Protect conditions are met, and that varies depending on the make and model of amplifier, depending on how they've designed it. But typically amplifiers will go into Protect as a result of DC offset on the speaker terminals, overcurrent across the output section, low battery voltage if it's a car amp, or high battery voltage again if it's a car amp, temperature too hot. So all those things are really going to just depend on how the manufacturer has set those protection points, but it's not really got anything to do with being Class D versus Class AB. Sometimes an amp will go into Protect for no reason if there's a fault with the protection circuit itself. That can happen. But that's the only time that an amp will go into Protect for no reason, as far as the amplifier circuit is concerned at least. So I fitted a couple of new drivers here, but I'm a little bit skeptical to power this up without those other capacitors fitted. I don't know what values they'll be, so we'll have a look at the data sheet for the 8244BB, just see if there's any hints as to what maybe we could put there. Oh, it's about that Class AB, yeah, no worries, I thought it might be. So, do we have an example circuit here? No, not really. Nicholas says 100 nanofarad should be right. Oh, they're just decoupling caps, aren't they? Oh, there's me being silly and thinking that they are something between the input pin and ground, which they're not, or like input pin and a compensation or something like that. They're not. These caps are literally just across VDDI and ground. Yeah, we could drop pretty much whatever on there. That'd be fine. What we do need to do though is replace R13. Now we're missing the trace from here to R13. So a couple of options. I can fit a surface mount one and then run like a bit of lead from here to match up. Or I could just fit a through-hole resistor and solder it to the traces like we'd be doing anyway. So I might just do that. So we're going from this cap over here. I could like do a through-hole resistor around here and then to this pad here on this capacitor. Don't even have to scratch away any traces. I'm looking for a 4R7 or something similar. A 2.2 would be fine as well, I'm sure. Don't really want anything too big. Just because if there is a short, then that resistor won't burn open as quickly as it did originally, which we do kind of want to happen. I don't know if I've got any really small 4R7s. I think all my 4R7s are going to be quite high power. Florida man, how's it going, y'all? Good to see you, buddy. Thanks for dropping by. Appreciate that. I've got a lot of nice small quarter watt 10 ohm resistors. I think 10 ohms is going to be a little bit high. What are these? Uh, 10. Now, you know what, let's drop in a surface mount and let's run a lead to it. Just because then it will behave in the same fashion as the original one did. If there is another short at some point in the future. Any exotic amps come onto the rack recently? I fixed 7 Camco Vortex 6s. Oh yeah, I actually was live streaming those for a bit, and then I got stuck. But I managed to figure out what the issue was and I fixed them. So that was pretty exotic for me. I don't usually do PA amplifiers, so that was good fun. Anything else exotic? Let's have a think. I've got a Paris 15K, I don't know if that's exotic. I've got an Audison, big long Audison that's quite fun. I've got a Paris AC to DC power supply to fix. I definitely have had some interesting stuff, I just can't remember off the top of my head now, but I'm just looking at the ones that are currently still in the workshop. So these little traces under the resistor, they should be fine. Yeah, they're fine. Right, now I just need a little small lead to run from there to there. Very nice. There we go. Okay, now before we do anything powering this up, I just want to check, because I actually forgot to refresh the solder on these pads before I soldered these chips down, which I usually do, but forgot this time. And so the solder is the original from factory, which is probably lead free, which takes a bit longer to get heated up. So I don't super love how some of these solder joints look, so I'm just going to tack over them with my iron just real quick. Oh, I got scammed, by the way. I got scammed by UT Source. Has anybody else got scammed by UT Source before? I've had good luck and good success purchasing end-of-line stuff from them in the past. I needed a integrated amplifier IC chip for some home theatre plate amplifier. And I had a few options. I could either buy it from an eBay seller, I could either buy it from UT Source or AliExpress. You know, no reputable places had any, obviously, because they're end of line. So I've had good luck with UT Source buying these kind of TDA and fully integrated amplifier chips before, and they've worked fine. It will depend, obviously, seller by seller. But my thought process was, if I buy a used chip from UT Source, then it's got a much higher chance of it being a genuine one. That's been taken from recycling, a board, that's being recycled. So I thought, all right, I'll buy a used one because it should work, and chances are it's going to be legit because it's taken from, an original unit. So the chip arrived, and almost all of the pins on it are shorted together. So it's toast internally. So I'm currently getting a refund, or trying to. And I've bought one from an eBay UK seller because it's going to come here in like 3 days. I had to wait weeks from China for the UT Source one. So I'm just going to try my luck on eBay. If the eBay one's fake or doesn't work, then you've got eBay buyer protection, so it's fine as well. Very annoying. What? Alright, sweet. We don't need these caps in just for a power up to test that it works, because they're just decoupling caps to get rid of a bit of noise on the supply voltage, so we can replace those later. No problemo. But let's just check that we don't have any, you know, like shorts or anything elsewhere before we power this up. So, no more shorts across the VDDI. Let's just get rid of the flux from soldering there. This is a Taramps DSP 3K, and we had a little discussion about what the heck is the DSP for in a Taramps monoblock, because you can't program it yourself. So it's a fixed programmed DSP, and they're using it basically as a basic preamp with like low pass filter and stuff. Very strange. Yeah, okay, cool. I think let's go for a power up and see what it does. So rail voltage was here somewhere. There we go. And let's just have a check. Let's just check that we're generating VDDI. So we have 5.9 volts there. 5.3, that's about right. Okay, well it's not, you know, disappearing or shorting. Do we have any pulses PWM in to the chip on pin 1? Not yet, at least. So let's just keep probing the output FETs and see whether we get any Class D switching. So that's the rail there. Correct my scope cam, sorry about that. Okay, well we don't get any Class D switching, which is strange. But it does look like the drivers activate. So if I go to the scope screen right now, watch what happens as I power up. This is on the MOSFET drain. We get a little bit of DC, and then when the amplifier activates, it drops down to 0 volts. So that the drivers are definitely activating. Something's happening there when it comes to life. We're just not getting anything there on the outputs. So let's probe pin 1 of these drivers. Let's see if we get any PWM. I also might try feeding this with some input signal as well shortly, just to see whether that changes any of this. Okay, so there's no pulses on pin 1 of either of these drivers here, and both are sat down at 0 volts, which is, I'm trying to remember how these ones with the 8244BB. So usually with this being a full bridge amplifier, okay, we should have, from memory, if I remember this right, I'm pretty sure we should have one of these drivers has VDDI on it at idle and the other one has 0 volts, because they're like they need to be doing opposite things. That's definitely how it is with the 20957 full bridges. So, okay, we're not getting anything. Let's just try putting some RCA signal and seeing what happens here. And then we can check the other supply voltages. We've got some buffer drivers down here that might not be being fed with any supply voltage either. There might be some issue there. So, let's just whack in a bit of signal just to see if that does anything. going to probe the speaker terminal here, out of interest. Ah, interesting. We have a little bit of something. Very, very, very small. Very low amplitude. Barely anything going on there. And we are getting some pulses actually. Very interesting. Now, is this amplifier set up in a weird way? Ah, this is set up in a weird way. This is good. This is really good. This is really good for the channel. This is interesting. I was wondering when I'd see another one like this. Right. This is set up in a weird way. I think this amplifier is fully functioning now. Let's get both my probes. Right, so that's what we have on the speaker terminals. Now you might think that can't be right. You might think, how can that be right? That doesn't look right. How's that going to make a sine wave? How's a speaker going to react to that? Well, remember, a speaker is across the terminals. So one of the terminals, if you like, is inverted as far as the speaker is concerned. And look what we have. Basically a sine wave. If we DC off AC couple... Oh no, it doesn't quite work. So I wonder if this is now working and that's what it's supposed to look like. Let's connect a sub and see what the sub does, shall we? The DSP is putting out the audio as PWM. I think you might be right, yeah. I haven't seen one like this before. Well, I have seen one like this before, but it's been a while. It's been a while. So let's connect the sub, and let's see what the sub does. So, what's going to happen then with this sub? How's it going to move? Oh, I wish I had another camera angle. Maybe something up here. Right, let's try that view up there. There we go. So let's power this up with a little bit of a signal. Turn the gain down because I don't know how loud in relation this is going to be. Okay, I think the amp's up and running. Yeah, there we go. It's clean as heck. That is beautiful. I love this little thing. That's sick. That is really freaking cool. That's really cool. So what's happening with this one then is it's not your regular Class D setup. It's like the DSP is sending the audio data as like a stream of pulses rather than PWM in some kind of way, and then each half of the amplifier, each half of the bridge is creating half of the sine wave each, and they like overlap like I showed you on the scope there. So the only other amps I can think of that does this with the sine wave, there was a Stetson that I looked at one time that did this, and also the Kicker Warhorse, yeah, did this as well. Although the Warhorse did it in a different way. The Warhorse, you couldn't wire a sub like this. The Warhorse, you had to use a dual voice coil sub, because in the Warhorse, the two halves of the amplifier creating each half of the sine wave couldn't see each other. If they saw each other, then it would be very bad. This is different. So yeah, that's all fixed, but really cool. But what's the point of it? Like, what is the purpose of this? How high does like? You see all these settings on the side. There's no values. High pass filter, low pass filter. There's no numbers. Ah, it must show it on the screen. Yo, it will show it on the screen. So let's power this up again, and let's see what kind of, like, because this is a DSP amplifier, and because obviously the switching frequency, I guess, or the sampling frequency is going to be really high, because it's going to be whatever that DSP chip is outputting, right? So this potentially has the potential to be possibly a really nice sounding full range 3000 watt full range amplifier. Possibly. I'd have to do the tests on it, but compared to like the HD line, the MD line, all of those others, this potentially could be really good for nice sounding, very loud mid-range build. So let's power this back up again and have a look at what kind of frequencies it goes up to on the filters. Alright, so level doesn't change it. Hang on a minute, let's just go up here, get rid of that. So level, yeah, we've got a level number, so we've got a number for the gain. That's pretty cool. Now let's try HPF, high pass filter. High pass filter, full. So that is basically off, and then we go, we start down at 20, 30, 40, and we can keep going all the way up to 1000. Okay, so it's 1000. So the high pass filter, well, the potentiometer is dodgy. So the high pass filter will go from 20 to 1K. All right, interesting. So you couldn't run tweeters directly off this. Not that you'd need 3K on tweeters, probably. Low pass filter, we start off at 50. Okay, that's good. I mean, it is very dodgy. To get it on 50, I have to turn the potentiometer really slowly and really specifically. It's very, very fiddly. So 50 is the minimum. 60, 70, 100. Whoa. Okay. Okay, so then we've got full. Yeah. So we can open this up and play full range for sure. All the way up to 20K. And then bass boost. Bass. We've got a boost amount. You know what? I think that's freaking wicked. I don't mind that at all. I think that's cool. Why not? Try something different. I like the way it works. Very interesting. But yes, that is a fix. Shorted output driver with no shorted FETs. Very strange to come across that kind of failure, but there you go. Right, I think it's about time for an advert. What do you think? Do you want an advert? Would you like an ad? Wait, what do you mean enable monetization? I did enable monetization. Oh, monetization off. It's not. Right, now it's on. I definitely turned it on before this stream. It keeps turning it off. Would you like an advert, guys? Get me some money. Would you like that? There you go. I actually like it because it means less passive components, less phase shift. DSP crossover on amps are the way of the future. Yes, Clifford, I fully agree. Yes, absolutely agree. Obviously, going into a DSP, it's non-linear, so the audio is being converted into a digital signal, so it's being sampled. So there are losses there. No matter, you can sample it however much you like, but there are potential losses versus an analog signal. But given that the signal coming into this amplifier didn't start off as analog, it was digital at some form, whether it's being played from YouTube, Bluetooth, Spotify, CD. Doesn't matter, it's being converted back into digital, which is how it started its life anyway. So sampling it at a high enough sample rate is not going to degrade the quality at all in an application like this. And having all of the preamplifier processing done digitally like that, absolutely brilliant. Gets rid of all the issues that are surrounded by discrete or analog preamplifier circuits in terms of noise, in terms of phase shifting, in terms of THD, stuff like that. It's all just done digitally inside the chip, and then by the looks of it, the chip is outputting pulses that are being sent almost straight into the drive circuit to the output MOSFET. So you're basically, the output of this amplifier, you're listening to the output of the DSP chip, just like huge, just amplified without being changed in any form. Really cool. I like it. Really interesting way of doing it. Talking of drink, I could do with a drink of water actually. I forgot to bring my water up here. Let's put the lid on this. And let's crack on with something else, shall we? It would be cooler if you could control the DSP somehow. Yeah, I agree, because the DSP will have the ability to phase shift and all sorts. I mean, it's a mono amplifier, so given that the signal you're feeding this is going to be for your subwoofers, or not even for subwoofers necessarily, for a mono full range output, I guess you could apply EQ on that DSP chip. I didn't actually check if it had EQ. Probably does. You can apply EQ, you could apply time alignment, you could really dial in the crossover slopes how you like, etc. There's a lot that you could do with that DSP chip that you're not able to, just because there's no way to actually control it. I think that's pretty cool. I don't mind it. I don't hate it. I like it. I like it when you never see something like this from Sundown, Digital Designs. This is like from scratch in-house circuit designing. You know, this is pushing the boat out. This is trying something different. Let's have a look at this. This is an X-Fire. This is a 4-channel amplifier using TDA integrated amplifier ICs. This one says OK on the back. So does that mean it works? I'm not going to trust that. I'm just going to take the back off and have a little inspect myself first. So that amplifier is going back to another technician here in the UK, the DSP, the Tarrant DSP. So I assume maybe he will have kept the original decoupling caps. If not, then he can fit some replacement ones on if he wants, or not if he doesn't want. Oh, I was wrong. This is in fact not one of the Class D chip amplifiers. This is a Class AB. Huh. They all look the same from the outside, this brand. So we've got a Class AB, 4-channel amplifier with a surface mount discrete drive circuit and some transistors on the heatsink. Don't see a transistor on the heatsink to help adjust the bias as it warms up. It's probably this one that's closest to the heatsink here, which is not really close enough for super low THD and stuff. It's probably this transistor here that's adjusting the bias with the temperature. So let's just check, see whether any outputs are shorted. Seems okay. Power supply not shorted. So is this in fact okay? And if it is, why is it here? All these X-Fires have come from a shop. There's a shop that sells these. I think they distribute them in the UK, and they always send me boxes of various different models of these with varying issues. So I'd be surprised if they decided to send one that was okay, because that would be silly. I've got a question for you. I've got a Ruthless 4-channel 1500. If power is on but no sound whatsoever, the RCAs are fine. Wait, hang on a minute. Its power's on but no sound whatsoever. The RCAs are fine. All the settings all right. Where there should be there. This is hard to read. Sorry, man. All the settings all right where there should be. I can't even get distortion to come out. Right, first thing with that kind of issue is just clean all the toggle switches. All the little physical switches on the side like this. See this? Any switches that look like that, wiggle them backwards and forwards 20, 30 times. 9 times out of 10 that brings your sound back on those kind of amps with those kinds of issues. Usually those switches just go bad and prevent audio from passing. Input A and B, left and right. Okay. Let's turn the gains down in case they're up a little bit. They're up a little bit. That's fine. Just go down a bit. Okay, power up. We have power supply operation. Okay, now let's check for audio on the outputs. Okay, well, we've got audio on this channel. Check next one. Audio. 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 Why is this here? Well, that's £15 that you didn't need to pay. What do I charge for an inspection? It's usually 25. If I've got a shop that's sending me like a whole bunch, then sometimes I'll just do like £25 for a no fault found and £15 thereafter if there's multiple no fault founds, because otherwise it just ends up getting quite expensive for them and it's taking me like 5 seconds. How have I lost a screw? They literally went here on my desk. I'm sure it'll turn up in a minute. Right, that one's fine. No fault found. I'm just going to make a note of all these because otherwise I'm going to forget what the issues were with them. I do wiggle it back and forth while it's on, or do I... Listen, no, do it with the power off. Okay, so power the amplifier off 30, 40, 50 times. And then power it back on and see if the audio comes back. So, we've got one of them was blown power supply in one of them, in the X-Fire. In the Phoenix Gold we had, what was up with the Phoenix Gold? No fault found. X-Fire AB, no fault. Okay, next one. Like I said, I've got a big box of these from this shop. So this is a tiny little 4x100 Class D. Now, do I take this apart or do I plug it in and see what it does first, given that 2 out of 3 so far in this box have been no fault found? I think we just plug it in and see what it does. Plug it in at 18 volts. 18 volts, 250 amps. Oh guys, I've got some presents coming from Taramps. I asked them nicely and they sent me over a couple of things to play with. The first thing that they sent me over to play with is one of their new smart power supplies. So it takes 240 volts AC from the mains here in the UK and it outputs 200 to 280 amps continuous, anywhere between like 10 and 15 volts I think it is, for either using as a power supply for car amplifiers indoors, or more realistically for charging big lithium banks at shows and stuff where you are not allowed to have your engine running, or you don't want to have your engine running but you have a mains hookup. You can connect this power supply and you can charge your lithium bank as if you had your alternator connected without actually having to have the engine running. So it's a smart charger, so apparently it senses the requirements for voltage and current and whatever. I don't know, I'm going to check it out and see what it's all about. But the second thing that they're sending me is very interesting. It is one of their high voltage amplifiers. It's the 160,000 watt RMS high voltage amplifier. It can accept up to 350 volts DC as its power supply, and it can, probably for not very long, just given the size of the heatsink and whatever, but supposedly it can output 160,000 watts into 0.25 ohms. So I don't intend on connecting that to batteries, just put it that way, but I wanted to have a look at it on the bench. I wanted to see what it's all about. And in the UK, like I say, we have 240 volts AC mains here, and a funny thing is that if you full bridge rectify AC mains voltage here, 240 volts AC, you end up with 315 volts DC, which we could feed straight into this amp. So like in my head that works. I can't see why it wouldn't work. The power factor would probably be horrendous. It'd be all over the place depending on what you were playing with no power factor correction. But yeah, plug it in the mains, rectify the mains, plug it in. 160k. Well, obviously you haven't got that. You've got whatever your main supply can provide. But I've got a mate down the road who has 3-phase coming into his garage, and if you parallel the 3 phases after rectification, then the sky's the limit. There's big power available there. So we could have some fun blowing up subs, a lot of subs maybe, or I don't know, what else could we do with that? Who knows? Get an EV to put it into. Yeah, I could follow in the footsteps of Loud Fiat, perhaps do a big high voltage build. That would be pretty cool. Definitely be good fun. Right, so power supply going on. Let's see whether it draws excessive current. Nope. Okay, let's power it up and see whether we have any DC offset on any of these output channels here. See whether it comes on first. Okay, we're drawing 0.4 amps. We don't have a protect LED, we just have power. So let's zoom in on the scope and let's see whether we can gauge whether there's any Class D switching going on. Sometimes you can see the remains of Class D switching on this. Oh, okay. Right, I remember how these work now. We have, okay, yes, we have DC offset on some of these, but not all of them. That actually looks correct based on how these work. I've actually made a TikTok video where I repair one of these. They're very interesting. They use one chip, a fully integrated Class D chip that runs all the channels. And it works in a bit of a weird way, like you've just seen there. You've got DC on some of the speaker terminals, but not all of them. But from memory, that is how it's supposed to work, if I remember my TikTok correctly. But let's just plug my sub here into one of these channels and just see what it does. Based on what we've just seen there, the sub should push out or suck in, because it looks like there's DC offset on the speaker terminals. But from memory, I don't think that there actually is. I think it's just like phantom DC that then gets halved when you put a load across it. Okay, sub's connected. So let's see if we power it up, we get any DC offset. No, we don't. And so if we probe that now, we should see that we have DC on both. Yeah, we do. Yeah, so we've got 17 volts on both of those terminals. So that's fine. So is this going to be another no fault found? Let's give some RCA signal. I'm going to remove my sub just real quick there. We're going to get the RCA, plug it in. So channel 1, power up, channel 1. Okay, I'm not seeing any audio output there at channel 1 just yet. That might be because we need a load, because I've got a feeling we might need a load across there for the sine wave to appear. It's weird the way that these work, these amps. So I'm going to put my sub back in. Let's just turn the signal down a little bit. Power up again. So channel 1, input channel 1, yep. We're high pass, that would explain possibly why we don't have any audio. Let's go full range on both of these. Turn the gain down, just in case it's up a little bit. Okay, no, I'm not getting any audio at all. Okay, so maybe, just maybe, this amplifier does in fact have a fault. That would be nice, wouldn't it? Oh, we're green. So, let's check all of the channels on this. So we're well in channel 1, let's go to channel 2. Let's power it up again. And now, I've only got 9 volts here. From memory actually of these, I remember this now. I think I need much more than normal. So let's go 12 volts now. Yes. There we go. My memory, I think, serves me right. We needed a lot more than... Although maybe not, there's still not a sine wave there. No, wait. There we go, there we go. So sine wave output channel 1, sine wave output channel 2, channel 3. Nothing on there at the moment. Okay, maybe this does have an issue. Oh no, there we go. Switch on the wrong setting, and channel 4. Yeah, so that was fine as well. No fault found. So yeah, I like I said, I've done the repair on this one before, and I just remembered there that these ones, I think, what voltage is it they need? I think they need above like 10.8, and 99.999% of car amplifiers will power on and function with like 9.2, 9.3 volts. And that just keeps things nice and safe on the rail voltage and stuff if there is a fault. But yeah, that seems to be working just fine. So maybe this is a box of ones that work, but one of them definitely was bad. So King Ping says, where's the ground on the scope? It's through the mains, my buddy. The scope and my bench power supply share a common ground, so they're grounded to each other, therefore you don't need the ground probe. Unless you're probing like tiny, very, very low voltage, very fast frequencies where you need no noise on the screen. Okay, so that's a no fault found. Lil 4 channel, no fault. This is another one of those, I think. Now, the chips in these are very expensive. I think they're like 25 or 30 pounds. So the repair bill to change the chip on this is actually quite expensive, considering the size of the amplifier, because the parts cost is like quite expensive for what it is. RLG222, dude, you're my favourite audio repair guy. I wish you worked with customers in the USA. I'd love to. Thanks for the kind words, by the way. I'd love to, but shipping is extortionate, and the import tax and duty is a pain in the butt, and the shipping doesn't always take care of stuff on the way back, and I can't give any warranty to any work I do to overseas, so I just don't do it. It's just too many headaches. I'd just rather not get involved, unfortunately. Yeah, it's a shame. I'd love to be able to help you guys out, but there are plenty of really, really good technicians over there in the States that can sort your stuff out for you. What chip do they use? Off the top of my head, I can't remember, but you can find out if you go to my TikTok, but maybe you don't have TikTok, which is understandable. Not everyone likes it, but let's have a look. See if I can find it. This is my TikTok profile, and I got lots of fun stuff on there. It's really good. I don't watch anything on TikTok generally. There's a couple of channels I watch. Sinewave02 is fucking awesome. I like watching Loudfears. I like watching like EXO's stuff, and there's kind of a couple of guys on here I like watching. But I don't sit there and scroll through my For You page. I'll actively go to someone that I want to check up on. And now let's have a look. Where is it? One of these somewhere. Here we go, here it is. This little 4-channel Class D's got a weird fault. When we power it up, keeping the voltage nice and low to start with, we have good power supply PWM, got a main power LED with a little blue LED on the board that then goes to red. I don't know what that means, but let's check what we've got on the output terminals. Now the active terminals connected to the amplifier are channel 3, clean output. Channel 2, I'm not going to touch that. We need to turn our attention to this chip and its inputs and outputs. So these 4 thick traces are our outputs from the chip that will have Class D switching on them before the filter network. So let's just check these for Class D switching. We've got switching on channel 4, switching on channel 3. Channel 2, we just have the 12 volts DC. Channel 1 has about 2 volts DC. So the 2 possibilities, either the fault is within the chip itself, in which case we'll just have to order a new one. These are very expensive as well. Or it's a problem with supply voltages leading to the chip for each of the channels. So let's check that first. The external elements are pretty simple. There we go. TAS5630 BPHD. That is the chip that these are using. Yeah, EXO's freaking wicked, man. Met him in real life. He's yeah, awesome guy. Sadly, he's going through a couple of things at the moment, so I follow his EXO Big Deal channel as well, and yeah, he posted a pretty heartfelt video on there recently. Yeah, go check it out. So what do we think then? Is this one a no fault as well? Power this up and see what this is doing, shall we? Now this one, we have 0.8 amps idle. Is that? Oh no, that's about right. So let's have a look, zoom in for Class D switching. Yeah, we've got Class D switching on that channel. We can see it just peaking there. AC couple, zoom in further, reject low frequency. There we go. So we've got a Class D switch wave there. Class D switching, Class D switching, Class D switching. So all 4 channels are operational in terms of Class D at least. Let's just run some signal in and just see whether it's outputting audio. Why are all of these no fault found? It's kind of nice in a way, because it means that I get through stuff quicker, and these kind of repairs are never big earners anyway for me, but it is kind of annoying because it means that I'm not going to make any money off these, really. Right, audio on channel 1, audio channel 2, audio channel... Oh, that did something strange there for a minute. A little bit of DC offset as we apply the signal, that's fine. As we plug in the RCA. Channel 3 does act a little different. So channel 4 when we plug in, just straight away, a bit of DC offset there because we're plugging it in. Channel 3 on the other hand, similar. Channel 3 does behave a little different, but I think that's fine. Yeah, it's definitely outputting audio. No fault found. These ones that are no fault found, what I will do is I will obviously say to the shop, the owner, I'll say, look, done a quick test on these, seem to be working just fine. What issues were you experiencing with them? It could be that these are customer returns where the customer had an issue somewhere else in the system and believed the problem was with the amp, but it actually wasn't. That's what the most likely thing is here. So I'm going to ask, obviously, what issues were you having? And if he says, oh, this one had like an intermittent fault where, you know, after playing for half an hour it would do this, or he might say channel 3 was like pushing the speaker in or out in a strange way, in which case I'll look at it further. But I don't really want to spend huge amounts of time diagnosing a problem that might not be there. If I do a quick test and it seems to fire up with audio on all 4 channels, then I'll inquire further. If he says, don't know what the fault, it says OK on the back. Why are these being sent? This one also says OK. I don't get it. Why would you send amps that you know are OK? Maybe the wrong box was given to me. Maybe this was a box of OKs and there was another box of failed amps. And I got given the wrong box. Well, they're getting charged for this anyway. I mean, I guess this is like, what, £25 for the first amp and £15 thereafter. Each of these, £15. How long is it taking me to go over these? I'm streaming as well, so it takes longer, but I'm probably making okay money just like testing these and getting £15 per test. So I'm not even gonna bother opening this one. We're just gonna go ahead, plug RCA straight in. $12 straight away. Let's go full. Yep, full. 4-channel mode, yep. Speaker A, power up. Okay. So, sine wave on that one. Sine wave on that one. Sine wave. Sine wave. There you go. I'll have 15 quid. Thank you very much. Strange. Okay, awesome. Let's have a look at, what should we look at next? We've got an Orion, old school Orion with a preamp fault. What else have we got up there? Oh, okay. I can either have a look at this, which I'd quite like to look at, because I'll get paid really decent money for this. This is a 4,000 watt. I think it's like 2.5K, or maybe it is 4K. 4K monoblock. This is a Xenon Korean full bridge. I think these ones are full bridge, these little ones. The big ones definitely are. It's a full range monoblock from Korea. Or we can have a look at this. Soundstream reference 405S. And note from the customer says, the amp doesn't power on. Would be great if you could give me a repair estimate. So seemingly we have no power for this one. Yeah, let's have a quick look at this Soundstream. Oh, the Vibe. You want to go for the Vibe? What do you reckon? Vibe or Soundstream? Let me know. Yeah, Vibe. Alright, sweet, let's do it. I thought you were all going to say the Soundstream there, not going to lie. Right. Now this didn't come with a note, but I do have the customer's details on the postage slip. Soundstream is what you see all day. I don't really see that many soundstreams. This is what I see all day. Wait, why does this case say IRFP 1405 on it? I didn't write that. That's not my handwriting. Ooh. Maybe it says IRFP 1405 because it needs some IRFP 1405s in the power supply. Ooh. Okay, no worries. We have at bare minimum then a power supply rebuild on this one. Possibly also an output section rebuild depending on what's going on. Yo, Tom for the 5! My man, thank you so much for your very first donation by the looks of it. Keep up the good work. Learned a lot as a basshead watching your videos. Man, I appreciate the support there. Really, really nice of you. Very, very nice of you. Thank you so much for the €5. I think that is, bro. Whereabouts are you coming out from? Somewhere in Europe. Thank you very much for the kindness there, buddy. I really do appreciate that. I'll go towards some more flux. Oh god, these ones are always very hard to get off. I'm doing the safety squint. I'm going to put the safety glasses on just in case they ping off in my face. There we go. Yeah, these amps have some of the toughest to remove clamp clips. Sheesh kebab. Boomer Bus Season 2 when? We're going to talk about Boomer Bus Season 2. We're going to talk about Boomer Bus Season 2. We're going to talk about it after I've had a look at this amp. So stick on the stream if you want to find out a little bit of info about Boomer Bus Season 2. Did everyone see the live stream that I did for the Boomer Bus Season 1 finale, where I tested the... What did I do? I tested the... I think I tested the new Dayton... Did I test the new Dayton driver? I can't remember now. Yeah, I think I did. I tested the new Dayton driver that I'm planning to use for Season 2, and it freaking walked all over the Peerless driver that I've been using for Season 1. It is awesome. What a beast. Yeah, that small Dayton did a 151.9, I think it was, in the Justin T line. Look at my community post. Go on my channel right now. Look at my community posts. And you'll see, if you haven't already, that the Dayton did a 151 in the Justin T line. Not on 15 watts, obviously. I was pushing it hard just to see what it could do. Yeah! But I've got 4 of those drivers, so we can have some fun with Season 2 with multiple drivers for sure. Oh guys, I need to show you something. I need to show you something that I found on Facebook Marketplace that I really want to buy. That would make for some incredible videos. I gotta show you this. I really want to buy it, but I think it's gonna be ridiculously expensive for what it is. Right, check this out. Come on, let's open it up. Come on, open up. Open it up. Why is it not opening up? Right, here we go. See details. Right. Right, check this out. This is a kid's pedal car, okay? It's a Royal Mail van, Postman Pat little freaking kids pedaling car, but it's been converted into like a little electric powered ride-on car, okay? Now, at first glance, you might be like, what the hell? Why is that cool? The thing that's cool about this is because it's a freaking fully enclosed mini vehicle. Kids' Power Wheels are almost, like, they're pretty much entirely always open top, like, you know, without a roof, so the kid can step in and out. This thing has a full back and roof, so you could wall that thing off with, like, a couple of 6-inch subs or something, a couple of 8s, a couple of 6s, maybe some like 4-inch sub. I don't know. You could do some hilarious stuff with that. You could put windows in. You could have the door flapping around. You could fit some high voltage batteries. I could run like, oh man, this would be so much fun to make videos with. And it's only around the corner from my house. Literally, it's down the road, for sale down the road in my house. But the guy, I said, what price do you want for this? And he was like, oh, I don't know, the last one of these that was in really good condition sold for £750. And I'm like, oh, so he's probably going to be wanting like, I don't know, 400? 300, 400? And that's like getting on for the amount of money you can pay for a real functioning roadworthy car, albeit an older one that's maybe a bit dented with bad paintwork, but you can get fully road legal cars that run and drive for like £300 to £500 up this way where I live. So like that kind of money for a kid's ride on, do I really want it? Like I could just buy a car to do some fun experiments with. If this was £100, I'd go buy it. But I don't know if I want to go and spend like £300-400 on it. Throw the 160k watt amp in it, yeah. Do you still have your base van? I do, yes. But I don't know. What do you guys think? I don't know. Part of me is still vaguely tempted. Part of me is still vaguely tempted by that, just because it will be hilarious. So, oh man, the RCAs are absolutely screwed on this. Okay, yeah, part of me is slightly tempted. So the most recent video that I put out on YouTube, which was with the B2 Audio 2-inch subwoofer, so that has got to be one of my best performing videos in years. And I'm still going to make some more content on the B2 mini sub. Spoiler alert, I'm going to make some headphones using that sub. So that's going to be fun. But that video has earned me, I think, like £450 in ad revenue from that video. So if I spent like £300 on the Postman Pat van thing and made a sick video with it, I could probably make the money back if the video did well enough. I don't know if the video would do well enough though, but who knows, maybe it would. But if I got like 3, 4, 5 videos out of it, then it would probably pay for itself and then bring in some money. I don't know. Do a GoFundMe. I don't know if I want to do that. I don't know. Maybe. The problem is if I do a GoFundMe, then it puts pressure on me to make content with it quickly and, you know, to actually do something with it. Whereas if I've paid for it, then if I don't make anything with it for a while, if I'm busy, or if I decide, hey, this isn't really working out how I wanted it to, or whatever, then, you know, it's not like people have thrown money at something expecting a result and not got it, you know what I mean? Respect, fam. Wade, watching from Jamaica. Appreciate you, bro. Big love. Hope all was good over there, my friend. I've seen DB drag where 2 B2 rampage 2 inches reached 121 dBs. Yeah, I wouldn't put it past them. I mean, I know it's obviously much smaller, and the box, you know, the cabin is much smaller, but in boom or bust, we're hitting legitimate scores of 145, 150 dBs with enough power. The scores are real. The scores are not scaled. Obviously, the dB is correct, is real. Just everything else is scaled. Okay, so we have cooked power supply FETs. Yep, these are RF-P 1405s. Now, are the power supply FETs cooked because the output FETs are shorted as well? Let's flip it upside down, have a look with the multimeter. Okay, on that side. No, the output FETs appear to be not shorted. So why did the power supply fail? Very uncommon. 1405s are very resilient. Vibration damage possibly? A reverse polarity connection to the amplifier? The only way to know for sure, I think, is going to be to fit some new FETs and possibly drivers if it needs it. The gate resistors don't... and there is a burnt gate resistor actually. I was going to say the gate resistors look alright, but no, there is a burnt gate resistor there. So let's chop the FETs out first. The terminals don't have any signs of arcing, but that's not a reliable telltale sign of reverse polarity, like sparks and arcing at the terminals. That doesn't tell you that it was reverse polarity connected, because you get those kind of sparks and arcing when you connect the amplifier up in normal polarity anyway. When it charges the caps, you get a big spark that can create marks, as I've seen plenty of times before. So that's not a reliable telltale sign that it's been connected in reverse polarity. The only accurate telltale sign for a reverse polarity connect is that the reverse polarity protection diode has been blown to bits or is shorted, or that there are lots of dead components that don't usually die that have ground and 12 volts as part of their connection on them, like the transistor that creates 12 volt VCC for the 494, that has ground and 12 volts on it. The NPN transistors for the drives, the drive transistors for the power supply FETs, the drivers, they generally die with a reverse polarity connection event. The capacitors, the power supply filter capacitors, if they're all vented or bulged, then that's another telltale sign. Now this thing only needs 4 TO247 power supply FETs. I wonder if I've got some in stock. I should do, really. But needing only 4 FETs of the same batch is a good way to use up some remaining FETs from like a specific batch. If I've bought a whole batch of like 25 or 50 MOSFETs and I only need to use a certain number of them, sometimes you can end up with having like 4, 5, 6 left at the end of the batch that aren't really useful for anything. Apart from sometimes like this, where you get amps that only use a few of them and you can finally use them up. I'm always a bit skeptical though when an amp fails like this with a power supply with no obvious sign yet as to why. Why amps don't do PMOS reverse polarity protection? I guess because it's the problem is with car amps, right? Is that the supply voltage is so low, which means that the current is so high. So even though MOSFETs have really low on resistances, the on resistance of a MOSFET is magnitudes higher than any cable or connection point along the power path. So that MOSFET RDS becomes a huge current bottleneck, and that MOSFET is going to get really hot. Yeah, if you think about it, like 1 or 2 or even a bank of 4 MOSFETs dedicated just to reverse polarity protection. The MOSFETs aren't even being used in switch mode. You know, well, I guess you could have them switched, I guess, but in the basic form that you're saying about, they will just be being used to pass DC current, which they're gonna freaking cook. That's why it's not used, it's not done, you know. Car amplifiers are just throwaway devices anyway. They're not designed with any kind of insane inherent protections against that sort of thing, and they're not designed to last like 20 years. They're designed as quick profit machines to satisfy a customer for a short amount of time. There are obviously exceptions to that rule. There are some brands that really do design stuff really well and take care about it, but car audio in general is just a quick fix kind of type of equipment. Have you ever heard of Admark amps? No, I don't think I have. Doesn't ring a bell to me. Admark, not something that I recognise. Okay, there was also a couple of gate resistors that looked pretty worse for wear, so I'm probably just going to change all the gates. What we got? This one here is toast. What is it using for gates here? I think that was the only gate resistor that was visibly burned. We've got 22s. Okay. That one's open as well. So yeah, let's replace all of these for fresh 22s. The fact that the gate resistors were burnt probably means that the drivers got hurt as well. So we'll have a check for some PWM shortly. Right, let's just do a quick check on the drivers with the multimeter, because that will obviously tell us if there's any super dead ones. Well, there's none that are shorted or anything, or super low resistance, so might have got away with the drivers being alright. So, gate resistors. Some 22s would be nice, but I'm seeing a whole lot of 10s right in front of my face, so I'm just going to put some 10s in. It really doesn't matter at this level. 1405s are good with 10s. As well as 22s. 10s will be fine. The thing I like about the last video was you didn't miss the 144 that was bad on the second gate. No nightmares. 144 that was bad on the second gate. Can't remember what that was now. Oh, the 4148. Do you mean a 4148 diode that was bad on the second gate? Right. Yeah, that causes headaches because the amp looks like it is working fine. It doesn't really show any signs of being a problem unless you have a thermal imaging camera, and then before you know it, it's back in the workshop again because it's failed after not much time. Dubcrack says, good evening from Berlin. Nice to see some amp repair again. Yeah, man, it's been a while. Been very busy. So yeah, let's talk a little bit about Season 2 of Boom or Bust. So for Season 2 Boom or Bust, I have a big plan. I'm not really going to go too much into what the big plan is here, because I think it will be great to be a surprise. If I can pull it off, but in order to make Boom or Bust Season 2 happen, I need the PT Cruiser. There is an American company called New Bright, and in the early 2000s they made some 1/6 scale RC cars with fully modelled interiors and windows and everything like that. They're really cool. They're just cheap toys basically, but they're fully modelled 1/6 scale RC cars, which is like exactly what I need for Boom or Bust, right? That would be freaking sick to have a proper car cabin shape with the cabin being a bit lossy, you know, being plastic and being a little bit lossy. My wooden kind of test cabin is too perfect. It's too much like an extreme SPR build. Doesn't really resemble the real cabin of a real car particularly well. So I need that really badly to make Season 2 the way that it is in my head work. There is one for sale in the UK, but it's like a 7-hour round trip, and it's very expensive as well. It's like £200. So it's £200 plus a 7-hour round trip. And I'm just like trying to find time out of my day to do that. And yeah, it just seems like I've been messaging with the seller to try and see whether like he's driving anywhere nearer to me or whether he's willing to post it, but he's not willing to post it because yeah, so it's a bit of a pain in the butt. I'm trying to get a hold of it, but I don't just want to drive a 7-hour round trip just to get this one thing. I don't have the time for that at the moment, so we shall see. But that's the thing that's kind of in the way at the moment of me progressing with Boom or Bust Season 2 plans. It's been a while. Hello from the States. Hello from the UK, my friend. Right, ground and power and remote. Do we have decent PWM on all of these? Please, please, I would love it. I would just love it if the drivers were okay. Right, let's have a look. So, on this one. We've got nothing at the moment. We've got a protection light. Ah, voltage I think is too low on these. I think these need a bit more voltage. 12 volts now. Protection. Still protection. Okay. So the only reason it'll be in protect is if there's a protection circuit fault, because it doesn't know anything yet, because it hasn't got any power into the output section or anything yet. So the only reason it'll be in protect is, oh wait, no, it's gone green. It's now gone green, but we still don't have any pulses on here. Okay, what's the 494 doing? Did the 494 fail in an extremely rare event? Okay, no pulses on the 494. 494 pin 3 needs to be low. It's not. Pin 3 on the 494 is high, which means that the 494... Ah, found the problem! I found why this amp failed, guys. I know why this amp failed now. All of these pins are snapped. Pretty much. There's like 3 holding on for dear life. Right. So that all needs to come out then. And we need to put some new pins in there. Alright, how many, oh, so many pins, guys. So many pins were snapped. What the heck? How was this thing even still functioning up to when it failed? Jesus. All of those, and then like 1, 2, 3 on this side. Shee. So yeah, gonna need a new set of pins on that. Fortunately, I think I have some donor cards that have this style of pins on it. I can probably just steal. But yeah, this amp will work fine now. We know what killed it. So yeah, new FETs in there. This is gonna work fine. That's cool. What else was we gonna talk about this evening? Wheel Bus Season 2. I showed you the Postman Pat van that I want to buy and do a fun build with. Maybe I will. Maybe I'll buy it if it's cheap enough. What price do you think would you say that's worth to do a build, to do some YouTube videos with? Let me show you again in case you missed it. See, it's this. This is currently on Facebook Marketplace. It's a kid's Power Wheels, but obviously it's a fully enclosed van that you could wall off and turn into a miniature demo monster. Proper hair tricks, like miniature hair tricks with this, batteries. It would be so funny. But I think he's going to want like £300–400. It's like, no. This isn't far away. This is literally around the corner from my house. So naturally it's very tempting. Yeah. Not only could I make it loud bass wise, I could like put some really high voltage motors in there and like do skids. 200 to 300, 200 to 250, 250, yeah, alright. Maybe I'll offer 200 or 250 and see what he's saying. Frank says I have 6 new Solo X15s. I'm considering 3 of the new Kicker Warhorse. Nah, man, don't do it. Right, Kicker engineered and made those Solo X15s from scratch. Awesome subs. Now, I'm not saying that they didn't have a lot of doing in the R&D for their new amplifiers, but their new amplifiers are extortionately expensive for the power that they are. Power these days is very cheap. And because of the advancements in IC, semiconductor, Class D audio chips and stuff like that, to build a reliable amplifier isn't as difficult as it used to be anymore. Because you can literally take chips that have full Class D drive architecture all built into them, slap them with a power supply and some output MOSFETs and an inductor and a filter, and you have an amplifier that works. And is, you know, on as far as the drive circuit is concerned, probably relatively reliable. So there are brands like Powerus, like Taramps, like Banda, like, you know, lots of these at the moment mostly Brazilian brands that are building modern amplifiers on modern architectures that are from scratch, and some of them are really bloody good, and they're so cheap. It's literally a no-brainer. Why would you spend 8 times the amount to get a certain amount of power with the Kicker amplifiers, and when you can spend an eighth of that money on amplifiers that are arguably as good, if not possibly even better, and have more money to spend elsewhere in the build, or more money in your pocket, or maybe even some money for some repairs if you need them in the future. You might do with a big build like that, who knows. yeah, my advice always for subwoofer application only, right? This advice doesn't translate to your mids and highs amp or your tweeters amp or anything like that, but the amplifier you're going to use for your subwoofer application, buy the most genuine power that you can for the least amount of money, provided it's relatively reliable and it's going to sound fantastic. The most important factor for subwoofer application is dynamic headroom, having power behind what you're driving. The frequencies are so low that any tiny differences in how the amplifiers might sound in terms of their sound character or anything like that is completely lost in subwoofer application. The frequencies are too low, the drivers aren't revealing enough. So big power, low cost, go for something that's been proven to be reliable and you'll be fine. Sam, can you Google the AdMark amplifier and give me your opinion? Because I see it costs a lot, and I don't want. It costs a lot, and I don't want to regret it. Give me the model number. AdMark what? AdMark what? AdMark. Let's see what all these are all about then. AdMark amplifier. It's a PA amplifier. Okay, I'm not going to be able to really give you that much advice because I'm not as experienced in PA amplifiers. I'd need a really good close-up picture of the board to see like what architecture is being used, see how it's laid out. I'm currently on Google at the moment. There are some board pictures, but they're from very far back and very low resolution, so it's very hard to see. From the pictures though, it looks like it's a lot of power in a 1U rack. In a 1U rack size. But yeah, I've had a look on Google, very hard to tell because it's not like a circuit layout that I'm super familiar with. So yeah, unfortunately you'll have to wait until either someone sends me one to have a look at on the bench, or someone else uploads a YouTube video going over the circuit. Don't know if they will, but yeah, I'm not really going to be able to help you on that one, I'm afraid, buddy. Without some very good close-up pictures of the architecture, chips being used, MOSFETs, etc., layout. But guys, that has been fun little stream. I feel like I got through a lot, mostly because most of it was no fault found, but there we go. We fixed the DSP tower amps. That was very fun, really cool little amplifier that. We discovered that there was no real issue with the band at 8K, no issues with any of the X-Fire amps really, and this Vibe here has vibration damage on the driver card, so yeah, nice. So I'll see you at some point for another live stream probably. I'm working on videos, I'm working on some subwoofer headphones with the little B2 2-inch subwoofer driver. That's going to be a fun video. I'm working on preparations for Boom or Bust Season 2. I might go and buy that Postman van, who knows, it depends how much he wants for it. But it would be hilarious, it would be so funny, and I've got lots of ideas for it. So yeah, you'll see something, and it's probably going to be something small B2 subwoofer related, because I want to follow up that video with another banger. Do you know what I mean? So yeah, guys, have a great evening, take it easy. Thanks for joining me. Thank you so much for everyone who was very generous with their donations, and I'll catch you all in the next one.